Thanks for joining us at the blockchain side stage at TechCrunch in Shanghai. I'm Michael Sena, and I'm here to just give a brief overview of Ethereum, where the ecosystem's at, and learnings that I've encountered over trying to build decentralized applications for the last year and a half. And a bit about me. So my name's Michael Sena. As I said, I'm co-founder and head of product at Uport, a self-sovereign identity platform currently being incubated at Consensys. I was one of the early employees at Consensys and have been a part of the growing of the organization from 70 to over 400 today. Uport taking it from an idea to over 25 people. And I'm a blockchain usability advocate. And so really what I'm here to talk about today is just where are things and give us a lot of momentum into the conversations for the rest of the day. Starting very basic. Ethereum is a platform for building decentralized applications. And basically it does this. So on the left you have a standard web server. It is a black box. It's where users' data is held. It's where application logic is run. And it's the standard architecture for building web apps. On the right, we have Ethereum. And so basically it is what it looks like. It takes the architecture and the logic that used to run here and spreads it out and decentralizes it. And so what you get here is sort of a more modern architecture, a more resilient architecture. The one on the left of a traditional server is where you log in. There is sort of one entity or centralized organization that's governing sort of the rest of the logic running on the platform. It is one node or one sort of logic center that's making decisions, and that's distributing this to other participants. And so they're executing what they're told to do. These types of systems have single points of failure, are less resilient, and are sort of the past generation of the internet. On the right, this is a state of existence that isn't so natural. It's not so relaxed. This state of existence is more decentralized, where the participants on the network are all making decisions, are equally participating in building consensus. And this one is hard to maintain. It requires that each of the nodes or participants in this open community and network are actively communicating and talking to each other. They're actively sharing information, making decisions. It's not something that's really built on efficiency, it's more built for resiliency. And so they're two fundamentally different use cases, but when you open up the application logic and when you open up applications to being decentralized, you have a lot of potential for new use cases. And so what does blockchain get you? It seems like to not be in this efficient state, to be in this decentralized state that requires effort. What you gain is a trusted public database with provable ownership, activity, and computation. And so basically what you get is the ability to build massive use cases. The ability to build use cases where building on centralized systems with a single point of failure is risky. Systems like identity for the planet. And so the way that a system to identify the planet could be built on Ethereum would be one that enables the planet to identify itself. So one that has no single point of failure and one that doesn't restrict access to anyone's participation in this network. The way that a system like this could be built on Ethereum is that normal people can use an application or an open interface to register their identity on a public network, which everyone on the network has access to, and they could legally sign transactions from their identity with no middleman. And so what this does is it builds an inclusive system with open access to a whole new set of applications that were not possible before. Secondly, track everything. And this is basically just a supply chain use case, but what the blockchain does is it has this fundamental principle of everything can become an asset there. So it becomes an object that lives online, that can be controlled by a private key and tracked because the blockchain is public and well-known and transparent. And with systems like this, you can shed light where there's darkness. You can track things from tip to tail, from input materials to finished product. And you can build these systems and integrate them into the current supply chain infrastructure today, such that when something is manufactured, it's automatically registering an identifier for itself on a public network, and this identifier can be tracked by different interfaces that can come together to build a supply chain platform. Thirdly, We can stop fake news. So if we have a system that's open and public, such as one that can be used for identity, you can attribute content to its source, the same way you can attribute digital rights content to the author of that content. So a song to a band, you can attribute an article to its source. And so with accountability and transparency offered by the blockchain, you have limited worry, and the opportunity to sort of spoof some of these systems isn't dependent on the network operator to be the filter. So it's not dependent on Facebook to filter out what's real or what's fake. It's actually, you know what's real and what's fake according to who the author is. Program self-governing organizations. The blockchain enables this new world where logic and application logic is decentralized and operates according to a set rules that can be known by everyone. And so with this, you can govern organizations that self-heal, that make decisions. You can bring groups of people that used to be separated by land and technology before into collective ecosystems that enable them to achieve things at a greater scale than have previously been possible before. And you can build new societies. And this is the fundamental promise of a blockchain, that it takes this technology and enables all these people to sort of collaborate on one shared platform. If everyone's operating under the same instance of truth, if everyone has the same amount of knowledge at any point in time and is in consensus as to what that is, you can bring people together in new ways like weren't possible before. And lastly, do good. And at Consensys, we're working on initiatives like this that I'll go into in a second. But the blockchain can be used for massive impact and the ability to do good in the world. It's basically an even playing field. There aren't any gatekeepers. There aren't any people that are making decisions. It's actually owned and governed by the people and participants on the network. And these people and participants on the network are us. And so if we're all on this common platform, it can be used to track shipments of aid, can be used to monitor impact and results. And there's transparency along the process. And so really what Ethereum and the blockchain are these open systems that enable people to come together and operate under a trust context that wasn't there before. And so where are we today? Why don't we have these applications? People have been working on this stuff for 2 years, myself included. Well, it's hard. There are a few things today that are preventing us from having the type of impact and scale that we can imagine. The first is scalability, and I'll sort of loop interoperability into that as well. But scalability is the amount of transactions that can go through the network. If we said, okay, Ethereum's great, let's run Facebook on it today, the network would crash. There's no way that Ethereum could support a network the size of Facebook today. So scalability is a core challenge, a core technological challenge for Ethereum that many people smarter than I are working on. Secondly, privacy. Privacy is a little bit more solvable. It's a little closer to being implemented. I mean, you have ZK snarks and you have other technologies that improve privacy. And basically with Ethereum, you can extract some of these technologies that are being developed on other blockchain platforms and plug them in as a module on Ethereum. But basically privacy is an issue because blockchains were built to be transparent. They were built in such a way that everyone knows what everyone does. And so if we want to take these systems and apply them in a real world context, users and individuals have some expectation of privacy that goes along with these. And just because a system exists on a blockchain doesn't mean people will no longer care about privacy. Lastly, and probably nearest to being solved, or at least some solutions being implemented that can solve this, is usability. And so usability comes in many forms. All of these needs today exist because Ethereum and these blockchain apps or these blockchain platforms are new. There aren't any patterns that exist today. We're really defining all of the patterns for development and use that there are. Like 5 years ago, there was no one telling you how you should build a blockchain application. And even today, we're finding new things out each time. And so usability we have from a developer standpoint, we need dev tools, we need frameworks and infrastructure. And from a user side, we need the ability to enable people to manage private keys, interact with blockchain applications, understand and abstract the core technical functionality of a blockchain, such as mining and fueling and needing Ether to use apps. Because if these applications will ever scale to the level we think they can, all of these things will need to be solved. And that's what we're doing at Consensys. So I started working at Consensys 2 years ago, and it was largely a research organization. There were a few people researching in very specific areas. So like, basically just pointing around the room like, hey, you solve identity, you look at reputation, you look at signing transactions, and you look at light clients. And so basically people were researching into individual verticals of the space. But Consensys set out to be a new kind of organization, a kind of mesh organization. If Consensys wanted to achieve having real impact on some of these core challenges to blockchain adoption, such as scalability, privacy, and usability, Consensys would need to bring together large groups of people early on in the development of Ethereum's ecosystem to solve some of these. The core challenge of that is that Ethereum is a decentralized technology, and one that couldn't support a centralizing company on it so early. So Consensys seeks to operate at a low level of the stack in such a way that it can't be centralized. So it designed itself to be and to mirror the technology that it's building on top of, so to be decentralized. And what that means is there's no one Consensys. There's no one person in the organization that is commanding and controlling the actions of others. Consensys is more topographical, meaning that different groups of people and different companies underneath the Consensys umbrella are operating independently and in such a way that is what they need to operate. So Consensys is more like a collective and less than a company. And all of these people are working in service of building the new social, political, and economic operating system for the planet. Big goals. But going back to the use cases we talked about earlier, those are big goals too. And a type of company that is going to develop applications that can have that type of impact is going to have to be a new type of company. And so that's what Consensys does. When building the new operating systems of the planet from a technological perspective, there's sort of some things that we're working under, and this is a general architecture. It's not too specific, but there are different blockchain platforms. There's an application logic layer, some of which can be decentralized running on Ethereum, some can run on web servers. You can store things in centralized or decentralized storage networks. There's a layer of microservices on top of that I'll get into a bit more in a second, and those are other smart contracts provided by other application platforms, other services that make using decentralized applications more convenient, and there's a front end. And it looks like the spacing is a bit off here. But Consensys is operating at all levels of the stack to have impact. So with 450 people and growing, we have a lot of surface area. So Consensys is a big company doing a lot of things. At the highest level of the stack and at the top of the funnel, there's a government and education piece that happens. Consensys Academy is working to educate new Ethereum developers all over the world and get them certified so they can become developers of these new world applications. Smart Dubai, we're the blockchain advisor of the government of Dubai in order to further some of these initiatives that they have for their Blockchain 2020 project. And so those things range from decentralized identity as well as education initiatives too. From a community perspective, we founded Blockchain for Social Impact, Enterprise Ethereum Alliance, the Decentralized Identity Foundation with Microsoft, and the Accounting and Blockchain Coalition. And those are sort of the education and marketing pieces that we do at the highest levels. And then going down the stack, we have applications such as Balance for Accounting, Ujo for Music, Grid Plus for Energy, and more. Some core components that exist as some of these microservices, so Uport with Identity, MetaMask, and Alethio, and we keep going down. And so Consensys, because of its size and scale and the type of impact it wants to have, is really developing all across the stack. And so a bit about what I do at Consensys and sort of why I'm here, and I'll be on a panel later today, so I'll answer more specific questions related to identity. But I'm co-founder and head of product at Uport, which is a self-sovereign identity network. And as I mentioned before, one of the ways that we can build a system of identification for the planet is by enabling people to identify themselves, individuals to own and control their identity and register this identity on an open network with no intermediary. So directly giving people direct control over their digital identifier and all of the related information pertaining to that identity. What we realized is building a self-sovereign identity network is going to require us enabling user interactions across all types of platforms. So Ethereum apps, web server apps, apps on different blockchains, in my VR headset, in my car, on my front door. And so a self-sovereign identity network really comes down to the ability to offering users the ability to manage many keys to many accounts across many networks. So building this system of self-sovereign key management is truly the core of what we're doing. And with that, we've also built Ethereum's user platform, because building a self-sovereign identity network requires registering an account on Ethereum. And so if I, let's say on my smartphone, hold the private key in my Uport application to an account on any one of the Ethereum networks, then I can use that account to interact with other application contracts. And so really, we built this identity network that we're initially applying to the use case of Ethereum, because this is where all the development is happening. And so here, an overview of some functionality. On the left, we have self-sovereign identity, which is sort of just you can think of it as an abstract identifier on the public Ethereum network. It's controlled by a private key on the phone. Ethereum app account, so every single app I want to use has its own unique account that is attributed to my identity. And the reason why we do that is getting back to the three challenges that Ethereum has: scalability, privacy, and usability. We're solving usability through key management and clear transaction cards. We can also take a stab and sort of push the envelope in privacy through smarter key management. And so, yes, the blockchain is transparent. Yes, every action taken by an account can be publicly visible. But you can separate a user or a person into many accounts. And those accounts are application specific. So at least now, I don't have one identity that includes all of my interactions across all of my apps and platforms in one place. But now I at least have a framework where my accounts are my identity for a specific app, and that at least segments and helps improve privacy by building pairwise relationships. And so this all enables you to log in, sign, and authenticate across applications regardless of where the app logic lives. It enables you to store verifications, credentials, and badges, which I'll go into a little more in a second. And enables you, with all of that, to back up your private keys. Because at the end of the day, a self-sovereign identity network is only as strong as the key management systems it offers and provides. And so there are many ways we're trying to solve this. Really what Uport does, and this is sort of a little technical, so I'll just quickly skim over it here, but basically the Uport mobile application is your key manager that controls your keys to authenticate into various contexts. And so whether these are your Uport smart contracts living on Ethereum, interact with other application smart contracts, which may interact with microservice contracts such as voting and governance and others. And users may, in that same session of using a decentralized portion of your app, may also want to authenticate into another portion. And so at the end of the day, users aren't going to care where the application logic is run, just as they don't care what sort of language you're running behind your web app today. So where are we today? Uport and Gnosis are live on the Gnosis Olympia Alpha. You can basically log into Gnosis with your Uport. You can sign blockchain transactions. You can transfer tokens. And in Zug, Switzerland, this has been in the news, and it's something we're really proud to announce. We've been working with the city of Zug for a while to issue digital identities on the Uport platform for Zug citizens. And so what we launched a couple weeks ago was this process by which citizens of Zug, which is known as Crypto Valley, can register their digital identifier through the Uport platform, then log into a web portal provided by Zug where they can fill in their information about their name, their Zug ID, and their address, and they click submit. And then they have to go sometime within 14 days of that submission to the Zug City office. And in the Zug City office, the city official would verify that the information I provided on their web portal matches the documents that I bring in with me in person. And so the clerk would do an in-person check on my identity and approve me with their Uport application. And what that does in the background is it generates a piece of data. It says, this Uport user, your Uport ID, is a citizen of Zug, true. They digitally sign it with their private key. And what this does is now it creates an off-chain piece of data. So this data isn't on-chain, it's off-chain for privacy and scalability. And it's issued to my on-chain identifier that I use to log in. So this really, for the first time, brings legal identification to a blockchain-based identity system. So Zug is officially the first government to adopt a self-sovereign identity platform. Obviously, our boy Vitalik always reminding us that with these types of systems, we always have to keep privacy as a main consideration, which is sort of that phase 2, and that some of these systems, while they may be convenient, we always have to remember to do things in a way that protects the decentralized nature of the core. So like you could achieve privacy through centralization, but that's not one way that we would want to go. And so reminding us the internet was supposed to be decentralized, and let's keep Ethereum that way. Thank you.